Hey, this is Jody with another weekly video. When you're learning how to TIG weld, there's not 100 things going wrong. There's basically about 3 things most of the time when you're first learning, 3 things that you do wrong. Basically it's this: too long an arc, too much torch angle, not shielding the hot end of the filler rod. And if you can cure those 3 things and always be thinking about those things, it's just going to make your learning process go a little quicker. So I set up a little lap joint here because a lap joint kind of shows this better than most joints. And it's 11 gauge cold rolled steel just wiped down with acetone. Now I'm holding a long arc, too much angle, and I'm not shielding that hot end of the rod with the argon. And see how things are going here. It's kind of like, it's more like gas welding than TIG welding because there's a huge arc plume and there's a big heated area, and I am not taking advantage of the concentrated heat of TIG welding. A little closer here, but not close enough. You see how that boomerang shape is forming, the C shape? The corner of the lap joint there is melting quickly, and the bottom is melting, but it's not fusing into the root of the joint. It's just bridging the gap. Contrast that with this, where I'm holding a nice tight arc, and I've got a little teardrop shape. The metal is flowing nicely into the root of the joint. Instead of balling up, the rod is feeding nicely into the puddle. That's what you want. You don't want it to blob and ball and fall into the puddle. Occasionally it will here and there, but you want to be able to meter it into the puddle. That way you get something like this, nice uniform weld, as opposed to this, something that looks like Fido's butt. All right, well, that takes care of the 3 things to watch for when you're learning how to TIG weld, but stick around just a little while and you'll see highlights of videos posted in 2013. It's 2014 now, it's February already. And what I do every year is I take all the videos I posted the previous year and put them on a DVD set, and that's how I support this video habit of mine. So it's on 4 discs because there's about 8 hours worth of content on there because it's a whole year's worth of videos. If you'd like to have this in your library, if you enjoyed what you saw in 2013 and you'd like to have this in your reference library, or if you just want to support what we're doing here at Welding Tips and Tricks, this is the way to do it. Now let's get on with the highlights. We're going to go fast. We're going to get bugs in our teeth. I'm going to try to describe a year's worth of stuff in about 11 minutes. Let's do it. I'm doing a little manual pulse TIG welding on some aluminum thin wall tubing here with a foot pedal. Here I'm using some thick stainless steel backing to weld a big gash in an aluminum part. Stainless steel backing traps the argon gas and also provides a way to cast the weld metal. Makes it a lot easier than welding without it. Here I'm using a torch switch on thick steel, using upslope and downslope instead of a foot pedal. And the same thing, using a torch switch, using upslope and downslope to manually pulse. Again on thin wall aluminum tubing, just using a torch switch. To fill an aluminum hole like this, use light amperage and let that cleaning action do a little work for you before you ever puddle the metal. And then as you're filling it in and tapering off with the foot pedal, keep that torch moving around to prevent leaving a crater eye. A ground for odd-shaped parts, round cylinders like this, or odd-shaped parts where you can't get a ground clamp on. You can just use some bare braided copper wire. You can even tape this to an auto body panel for MIG welding. Here I'm walking the cup, doing some build-up on these stainless steel shafts. And also, we showed some straightening stainless steel shafts with a lot of build-up and using a dial indicator and applying some forced cooling air to straighten the shaft. When you're doing a horizontal aluminum butt joint, you got to point that torch angle up a little bit. Sanitary stainless steel tubing, got to get a good purge. There's a couple of techniques. You can do some walking the cup. Typically it's done without filler metal. You can either walk the cup or you can freehand. Here I'm using a TIG finger, doing a little slight circular motion, about 40 amps or so on his 063 wall. TIG finger slides along that nice polished stainless steel really nicely. Got to inspect that root. You want to get a good purge. Tips for doing that: 6G, 2-inch 6G pipe. Hot pass is called the hot pass, but oftentimes it's the same heat or just a little bit hotter. You can mix helium with argon and make a 200 amp machine weld like a 250 amp machine. Multi-pass stainless steel welds, you got to keep them cool. Aluminum valve cover, welding a bung in aluminum valve cover. You're not always welding in a straight line. Here's some techniques for adding rod from behind the puddle. Settings for the machine. Vertical uphill T-joint, 3F T-joint. Techniques for that and how a TIG finger will help you slide your finger nice along that joint without smoking your pinky. Pause and step, keeping a close arc. Outside corner joints, amperage settings, low alloy steel TIG, 160 amps first pass, coming back over it with a second pass at slightly lower amps while maintaining an inner pass temperature of 500 degrees to prevent any kind of hardening going on in the high strength low alloy steels. No matter what we welded in 2013, we tried to show unique, instructive arc shots. Also, for getting better when you're learning, just doing a drill called the steel drill, welding left and right-handed on a piece of flat bar. Showed all that whole thing. Using 309 filler rod for welding steels when you don't know the composition on repairs like that. Here's an example of using the rule of 33 for pulse parameters for precise bead placement on something that might be machined off, where you wanted to add metal in an area that was mismachined or worn, where you want to really confine that heat. Inconel 82 filler rod. It works really well for welding medium carbon steels and even tool steels when the thing is not going to be heat treated and you don't want to harden the weld or make it crack. Thin wall tubing, like used for fabricating bicycles. Rule of 33 again, 33 pulses a second, and comparing ER70S2 filler rod to weld mold 880. Really thin wall tubing, about 030 wall. Techniques, filler rod, also using a big cup as well as 309 filler for certain jobs, extending that electrode way out there when you have to prevent discoloration. And just when you need to extend that electrode way out there, like welding down in a hole or up in a really tight spot. Walking the cup on some socket welds. Techniques for walking the cup using upslope, downslope, and no foot pedal. Did a couple of heavy projects like this big fixture. Heavy steel square tubing using spray pulse MIG parameters and a Lincoln Power MIG 350 MP. Ran through that whole project, fit up, how the strong hand table worked, some oxy-fuel cutting. Selecting the right size tip is probably the most important thing in getting a good smooth cup, even as important as having a steady hand. I talked about parameters on the Power MIG 350 MP using pulse spray as well as short circuit using CO2, and using 9010 gas for the pulse spray parameters. How about some 115 volt flux core MIG? Welded some little joints and tested them. Here's some 6G pipe tacking up, and also this little technique using a forward and back type technique with the lay wire, 1/8 rod, 1/8 gap, forward and back, no side to side movement, pushing that root up through there on the bottom, making the bottom look like the top. Then the hot pass, walking the cup, using about the same amperage as the root. And then the stick welding, 1/8 7018, not spending much time across the middle, pausing at the sides. Techniques on keeping that rod pointed to the middle axis of the pipe, and finishing this 6G joint out with 1/8 7018 Lincoln Excalibur rod. MIG welding inductance setting tips on MIG using a thermal arc 252i fabricator. Vertical uphill. Lap joint technique using the tracing the puddle little triangle technique, and then also cutting them on a bandsaw, polishing, putting a little acid etch on them to reveal the weld nugget, and testing the different techniques and how they penetrated. Also some TIG welding using lift arc on that fabricator inside a fixture using the argon backing gas and a big cup. I also did a project making a boom arm to hang a wire feeder on that never did quite get finished. I'm still working on that. I've got some ideas, but it's taking a little scratch in my head for exactly what I want to do. This is some aluminum MIG using that Power MIG 350 MP. This was kind of a heavy fixture that was going to be used to lift something. I don't really know what it was about, but anyway, I worked through the settings on that and worked through some distortion issues, and finally got some pretty good sweet spot settings down for wire feed speed and amperage and trim and things like that. And that's what the end product looked like, with a little
cylinder attached to it. Some different settings for trying to achieve the MIG-like TIG look, like ZT Fab on Welding Web. We worked on that a little bit and kind of dialed that in. Also some padding beads with 60-10 techniques there, swapping left hand, right hand, going right to left, 2 steps forward, 1 step back, kind of a pause, whip and pause technique. Now that's a really good exercise for when you're in welding school. I built a couple of bumpers in 2013. This was a little bumper kit from JCR Off-Road, just using some, just using a MIG welder and some basic fab techniques and basic welding techniques, but then also swapped over and used a basic Lincoln Tombstone buzz box for some of the stuff with a 7014 stick rod. Try to do some basic things like people do in their garage. Talked about when stick welding is better for getting in a tight spot like this where a MIG nozzle wouldn't even fit in. Again, using a 7014 1/8 rod. Also built a bumper from swagoffroad.com just using a buzz box, nothing but a buzz box and a 7014 rod. We'll show you some of that coming up. This is a 7018 rod. Swapped over to using a stick welding on some of the counterweights on that big fixture because all they were was just blocks welded on the end for counterweights, and thought, a lot of times on a Sunday afternoon when you're working in your shop and you run out of gas, you got to get the job done. Sometimes you have to revert to stick welding. And then also some more oxyfuel cutting techniques. On that same job there was some tubing notching that had to be done. So we showed some of that, as well as some plasma cutting tips and techniques for cutting the same notches, just using a straight edge and a drag tip. 2-inch 6G stick welding cover pass. We covered that as well as the TIG root pass and hot pass. But this is the cover pass using 3/32 Excalibur Lincoln 7018s. Tips and techniques for how to hold hand positioning for making that transition up the pipe. Right side as well as left side. And this is the bumper from Swag Off-Road where I built the whole bumper using nothing but a buzz box and 7014 rods. I did use 6011 for a little bit here and there where I had to weld downhill on the tubing with some gaps. This is welding those heavy toe lugs in, cranking that buzz box up good and hot with a 1/8 7014. And again, for some downhill action on the tubes, I used 6011 1/8 little buzz box. Then also did some multi-pass 7018 fillet welds just to test out some MTS machines, some MIG-TIG stick type inverter machines that some folks sent me for evaluation. And using that Lincoln Excalibur rod. And there were some projects along the way like this pulley fan belt cover for an air compressor that was in the shop that didn't have a guard on it. Doing some fusion outside corner joints as well as some add and rod. Now, if you think this kind of stuff would interest you, if you like to invest in yourself, get a DVD with about 8 hours worth of welding videos on it, you can go find out more at weldmongerstore.com. Again, thanks for watching.